we are going to talk about. All right, so what is Kalkwasser? For those who are unaware, it begins with calcium hydroxide. Calcium hydroxide, in this case, we're going to say hydrated lime, which is so called because one method of manufacture is to combine water with calcium oxide, which is known as quicklime. So a saturated solution of calcium hydroxide in water is called lime water, or in aquarium parlance, it's called Kalkwasser. And Kalkwasser solution has been employed in reef husbandry since at least 1973.
Yeah.
So it's been quite a while. The purpose of dosing Kalkwasser, there are multiple purposes. It does provide calcium to contribute to the calcium demand of calcareous livestock. And in reef aquarium husbandry and in coral aquaculture, that primarily means scleractinians. If you're raising zooxanthellid bivalves, another really important group, and the calcium that's contributed does combine with CO2 to yield calcium carbonate. The hydroxides contribute to increase the pH of the system water and neutralize weak acids that are produced in biological reactions. So again, if you want to get an idea of how this can actually work in your own system, go to our website and download that Kalkwasser calculator. It's a simple Excel file. You punch in a few numbers, your system volume, your rate of evaporation, and your rate of alkalinity depletion on a daily basis, and your rate of calcium depletion. And these days, you can probably figure that out with either the test kits that you're using or with the monitoring equipment that you have employed. As you punch those numbers in, it's going to tell you if you're replacing all of your evaporation with Kalkwasser, what's the change in calcium, what's the change in alkalinity going to be. So calcium hydroxide is moderately soluble in water. In fact, I would say moderately is probably being really complimentary where it's not deserved. About 1.49 grams of material will dissolve into a liter of purified water at 77 degrees Fahrenheit. And you cannot increase the saturation, the solubility of that solution by increasing water temperature. Calcium hydroxide has inverse solubility. Effectively, the colder the water is,
The more
the
you
more
can
you
get
can
it.
get in there. If you want to play around with that in your own systems by running a cooling line through your Kalkwasser vessel, then you should try it.
Well,
Why not?
well, that's the thing that also is so interesting down here in Florida. You know, in the summertime, we get to a P. I mean, we get to the temperature of our reverse osmosis vat that holds all of our RO water, DI water. It can get up to as high as like 85 degrees. You know, and when we're using that to mix up Kalkwasser,
Right,
we cannot meet the pH of 12.44.
right.
We can only get to like maybe 12.38, 12.39. So as the temperature, and that again, I'm glad you're talking about this because it's so important, because some people don't understand the fact that the warmer the water, the less value you're going to get out of it. So basically, even though it might be considered saturated at that temperature,
Right.
it's still not going to do the same thing as it would if you could achieve the 12.4, 12.44 range in pH in the solution. So at 77 and below, you can easily achieve the
Right.
12.4, 12.44. Actually, as a matter of fact, in the wintertime, if we have a cold snap around here for a week and say it's only getting into the 60s during the day, low 70s during the day, um, we might get our reverse osmosis DI vat might get down into the 60s, the
Mm.
temperature. And at that point, I remembered Andres, when he started working for me, it was colder. And I told him to make sure the pH was 12.44 in the vats. And he's like, it's 12.63. I'm like, not possible. And then I started thinking about it. I'm like, oh, wait a minute, it's cold out right now. So then it was funny because I said I wanted to do a test on it to see what would happen with cold water, colder water mixing up Kalkwasser, the pH going up in value higher than what I was used to seeing. To take that then a scoop of or a cup of that solution or a gallon of that solution and putting it, which is crystal clear, there's no undissolved Kalkwasser laying in the bottom of it, put it inside where it's going to be 75, 77 degrees, what's going to happen?
Mm.
And sure enough, it just settles out.
Right.
And you get a precipitate out of it where it goes out of solution and land and settles to the bottom of the vessel that's holding that solution. And that was, of course, you told me it was going to happen, and I'm going, I can't wait to see what happens here. It's just have fun with it. There's so many things you can do. And I had one guy that actually said he was going to put a mini fridge next to his daggone his tank, because he liked this. He didn't sleep in anything below like 78 degrees. And I'm
Right.
like,
Right.
well, okay, you're going to be able to do this, but you're going to need to cool that down. So he actually is one of the few people with an SPS dominated reef tank that is just chock full of SPS corals that has a super high demand. Because he used that mini fridge, he's able to oversaturate the Kalkwasser solution and get that 12.6, 12.7 pH out of it. And he's actually able to achieve a true value like I've been able to achieve. But again, we'll get into what I'm doing exactly down the road. But that is one way. If you're not able to achieve your 12 or the 8.28 as your set point for your pH to start dosing Kalkwasser. Again, we didn't touch on that too, but we dose strictly by pH, not by anything else.
Yeah,
And
we're
that's,
going to touch on that.
yeah. So bottom line, you can achieve exactly what we do, and I could even achieve it too, but I don't have I'm not putting a refrigerator that holds 500 gallons of that.
Well, we're putting a new system in now, and I'm going to approach this by running a cooling line from basically the system chiller is going to run a cooling line into the calc stirring vessel, and it will drop the temperature. I'm using solid state cooling, thermoelectric coolers.
Gotcha.
It's going to drop the temperature of that solution, I think, quite low. And so in that vessel, we'll be monitoring pH of the solution and temperature of the solution. And in that, I'm hoping that I'm going to a get it as cold as I possibly can, so that
Right.
we're getting a good amount of additional Kalkwasser to go in. So in that liter of solution, that the standard at 77 Fahrenheit, that your 1.49 grams are going to dissolve into, that's going to give you an alkalinity of about 40 milliequivalents per liter, which is quite a bit. pH of
Yeah.
about 12.46, calcium concentration of approximately 794 parts per million, which is, most people with experience in this may say, well, that's not very much calcium. 794 parts per million. I can make calcium chloride solution to over 150,000 parts per million, and you're telling me you can't get it to 800. We'll get into that in just a moment. But even with all of those numbers, because the constituent ions of the calcium hydroxide are depleted by biological and chemical reactions, there's no residual material remaining other than impurities after their incorporation in reef systems. And this is not the case with calcium chloride, which lowers the pH of the system and contributes to the chloride concentration with each application. So if we compare those numbers with anhydrous calcium chloride, let's just say we're going to make a solution, a very weak solution with anhydrous calcium chloride, where it's going to be the same purity that I referenced those numbers from for the calcium hydroxide. And calcium chloride solution, for those people who may not be aware, is the most common source of calcium used in 2 and 3 part calcium and alkalinity methods. It's very soluble, and as a result of that, you can make a very, very concentrated solution with it. And you can buy a solution very easily that's a very high concentration. I would encourage you instead to be using Kalkwasser and mixing it yourself. So assuming the same purity of components that I referenced for calcium hydroxide, 1.49 grams of calcium chloride dissolved into a liter of purified water yields a solution with a calcium concentration of 530 parts per million compared to the 794. Now, no one's going to take 1.49 grams of calcium chloride and put them into a liter, but this is just to provide you a frame of reference. There's no alkalinity present in that solution. and the pH value is approximately 6.97. The
Yes.
chloride concentration is about 938 parts per million. So that chloride is going to continue to accumulate with time outside of you performing some sort of water change with a lower chloride concentration than you are starting out with. So if your salt mix that you're using is providing at whatever salinity value you're mixing to, let's say you're mixing to 35 parts per thousand. If your chloride value is 19,900 and the salt mix you're using is mixing up to 19,500, then good, you are going to deplete that chloride concentration a little bit each time you perform a water change. If the chloride concentration of your salt is higher, then it's just going to compound the problem. That may not be an issue for too many people. It all depends on what salt you're using and
And whether it was
how
balanced
homogeneous,
ionically.
exactly, and how homogeneous the blend is. Be mindful of all of those things. So the big takeaway here is that the pH value of your system is going to decrease with application of calcium chloride solution. That's contrary to what you want, as we're discussing here in this discussion of Kalkwasser. So just touching back on Kalkwasser, if you're going to be doing this long term, you think you're going to make the commitment to go ahead and incorporate Kalkwasser application into your system, you want to use calcium hydroxide with the fewest impurities possible. I make sure that the material that we obtain is batch tested so that it meets the highest possible standards of purity available for calcium hydroxide. I'm not using some nebulous metric like it meets my
Right.
standards. No, it
Or
meets
it's
the
pharma
highest.
grade, or
Yeah,
it's
it
you
it
know,
meets the highest standards that are available is what it boils down to. So that's what we're looking for, and that's what we source.
yeah,
Um,
it shows. I mean, everybody that we've had that was incorporating Kalkwasser into their aquariums with the method, after speaking with so many different people around the country, around the world, it's been I got people in other countries going, how am I going to get a hold of your Kalkwasser then? Because the stuff that I have is obviously it's attributing to the aluminum level in my system, and I can't find somebody that's got a, how do I trust who I'm buying the hydroxide from? And there's a lot of different places that sell hydroxides, other companies other than your company. It's just a matter of whether they're making sure that they have the same standards that you have. And we don't know that. I don't know that. And honestly, I don't care to know that, but I do know that, when anybody asks me about Kalkwasser, I ask them if they're using yours, the Reef Blueprint or the Captiv8. And if they say no, I say, okay, well, then incorporate the Kalkwasser dosing. If you can't dissolve 100% in a gallon of water, 6.5 grams, without having a precipitate at the bottom or a settlement at the bottom, it's probably not the same quality. But again, I don't know until you get me an ICP after a month or so of dosing it to see what your multiple ICPs to see where your aluminum levels are going. That's the actual key that I've found to finding out how pure the Kalkwasser is how much aluminum is in it and how much is it raising it in these particular systems that are now incorporating it. And we can tell fairly quickly if there is impurities in there that are over what the standards would be, because my aluminum levels in my system are uh, very rarely do I ever see aluminum in them, for one. And two, if it is, I don't think it's coming from the Kalkwasser, because I think we've even sent your Kalkwasser every time we got a batch of it in. We send it out for peace of mind, that send it out to Gene. Say, hey,
right, right,
do an ICP on this real quick. Let me know what things look like. And it's funny that you say, because he basically does exactly like you said, takes the 1.4 grams and puts it in a liter of water, and then that clear solution is what he tests.
right.
And I remember the last time I sent it out, and the calcium value was like 760 or something like that on the calcium value, and I was like, oh, I think that's about what Chris was telling me it was supposed to be. Um, if it's all being dissolved in the right temperature and everything. So it was what did you say the value should be? Seven something? Seven?
Eight, 794.
Yeah, so his was reading at 760 with the ICP. So was there more water in there? So is it
Yeah, the
exactly,
temperature, likely
temperature?
right, the water
Exactly.
temperature. Yeah, and for those people who are unaware, who we're talking about here is Gene from Reef Labs, who
Yes.
is
Sorry.
the ICP provider being discussed. So before we get into methods of application or even preparation of the solution in general, it's very important for people who are unaware of or were unaware of what Kalkwasser was prior to this discussion to understand a couple of things. First of all, as we've talked about, the solution that's created is very, very high pH. It has to be dosed on a very gradual basis. Addition of Kalkwasser solution at too great a rate will drive the system pH higher than is generally recommended and can be catastrophic, causing loss of considerable livestock and easily the entire system if it goes too far. Potentially cause precipitation of calcium carbonate as well during in that process. The result there is a decrease in alkalinity and a tendency for pH to fluctuate further. And this can also occur when undissolved calcium hydroxide is dosed into a system. So Um, two things there. First of all, it needs to be drip dosed into a system. You don't mix a solution and then add it in one big shot. You don't take powdered material and add that to the system. You mix the solution up as we're going to describe. You dose that solution after it's had a chance to settle, and you are monitoring the pH the entire time.
Only the clear liquid.
Right.
And as we get into this, we can explain, what I learned and how we do and make sure that we ensure that there's only the clear liquid being dosed into the system. Again, and you touched made a good point, that it can kill your entire aquarium if it's overdosed. And do not put it on a gravity feed on a float. If that float fails, your tank is dead. So, we talked about this many times, but dosing it is, in my opinion, with a controlled dosing pump, is the way to ensure that you don't have
Right.
an overdose
Right.
from a gravity fall. Be mindful of how you're doing everything, especially when you're dealing with something like Kalkwasser, because I've heard horror stories. I've got people that have had the horror stories of dosing Kalkwasser that are now dosing Kalkwasser, well, that were dripping Kalkwasser with a gravity feed, and they wiped out their entire aquarium. Now I've got those people listening to me, seeing the results that we've gotten in our farm, and they're dosing it now, and they're just like, wow. Um, so there's multiple ways you can do it, and some of them are wrong, and there's others that are right, and then there's others that, in my opinion, if it works, keep going.
Yeah, so respect the material. This is part of the big takeaway point here is that with all of these, it's absolutely worth it.
It is.
Is it more effort to prepare? Yes, and to dose, but it's worth it. Beyond the shadow of a doubt, it's absolutely worth it. I mean, when you look at the amount of money that you have saved just in not dosing the calcium and the alkalinity as much as you had been prior. Just that by itself, plus the fact that your corals have increased their rates of growth dramatically in what 18,000 gallons worth of system or some massive amount of
Yeah,
water volume and
18,500 gallons.
yeah and a ton on probably a literal and figurative sense of coral in all of that. So it's absolutely worth it. Calcium hydroxide is dusty material and it easily becomes airborne. It is harmful to breathe, so it
Yes.
should be handled accordingly. If you're going to handle a lot of it, get yourself a dust mask, the kind of mask that you're going to wear when you're doing drywall work or something like this, or get yourself a 3M or something along those lines.
Yep.
You don't want to be breathing it in, and you will easily breathe it in. If you open up a bag of material and it slips out of your hands and hits the countertop,
Oh,
even if it drops an inch, God
a
forbid if it
dust
hits the
cloud.
floor, you're
Yes.
going to see a plume of material shoot up like this, which makes a big
Run.
mess because it kind of flies like
And just
a
cooks everything.
yeah, it does coat everything. It does coat
Run.
everything.
Just
Yeah.
run.
It's not going to hurt you, but don't breathe it in. So the other thing is this. I mean, and I say in a bag of our material, we don't provide this material in rigid packaging, and we don't do that because I would like you to carefully and slowly squeeze the air out of the bag and reseal it after you're done using it. The less it's exposed to atmospheric moisture, the less CO2 it's exposed to, the longer it will continue to have the attributes that we've been discussing here. If it's
Yep.
exposed to moisture, if it's exposed to atmospheric CO2, if you leave it the bag open and come back 10 hours later or something like this, some of it's, I mean, it's still going to go into solution. I would anticipate that your pH levels are not going to reach where they were previously. Whatever, just keep on using it. Use it till it's done. That's your
Yep.
one trial learning. Don't do it
Yep.
again. But
And
keep that bag sealed and keep as much air out of it as physically possible. Don't transfer the material into a bucket and seal it up because now it's exposed to that layer of air, which gets progressively larger as you are
yes.
removing material.
Well, we
Um,
I do a lot of precautions to make sure that we're in just a humid area environment down here. We keep it inside, of course, where it's AC'd, and I actually keep it in a small bucket inside the Ziploc bag. So we
hmm.
squeeze the air out, put it inside of another bucket. That's got a rubber seal. We seal that, and then I actually put it inside of another 5 gallon bucket and seal that down shut. Now that might be a little bit overkill, but that makes me feel better knowing that my powder is going to be in perfect condition. Every time I open it up, that there's not going to be a chance of atmospheric air, even though the barometric pressure changes constantly. Those rubber seals don't really help out a whole lot.
Well, whatever, man. I mean, as long as you're not allowing the material to be exposed to more moisture than or atmospheric CO2 than necessary, and where you are, especially because I mean, you're 50 yards from I-4, if that, 45,
Yeah,
50 yards, something like that. There's a fair amount of carbon emission that occurs. For again, for those who
just a
are
little bit.
unfamiliar, I-4 is a relatively well-traveled stretch of highway in the
Because
that runs basically between Tampa and Orlando.
actually it runs between Tampa and Daytona.
Ah, well,
Yeah, and it's actually was it considered the deadliest, most active highway in the country of 2010 or something like that.
yes. I believe it
So
because
it's
there are people, many of them who may be watching this, who drive like maniacs on that road. There are too many people driving on
I drive
I-4.
with the flow. You
Well, you
have
have
to
no
if you
choice. Yeah, that's true.
exactly.
That's true.
It's a crazy highway, but yeah, the I think that is the biggest contributor to my issues with my suppressed pH being in an open air environment, and I think it has a lot to do with it contributes to a lot of different things that we do there, especially with all that atmospheric CO2 not having the vessel being sealed properly that holds the solution, which I think we should get into on another episode, the mixing application and all those other things. I think we should touch that on the next one, but it makes such a difference. And I've got so many people that have came up with so many crazy cool ideas that I don't even think I've said them all to you to help keep that air away from the solution itself to keep it from being compromised. And we can go into that at another time, but it's going to be fun to continue going with the whole Reef Agriscience.
That's the beauty of farming is coming up
It is.
with solutions to stuff, even if you're reinventing the wheel and you don't know about it. But I
Yep.
will say again, having these conversations and reading up on the subject from the people who came before you who aspire to do the exact same things will often help you not reinvent the wheel and may,
Right.
if you're listening,
Yes.
that's the other part of this equation. So we'll talk a bit here just about the method of preparation, and we'll touch a little bit on application so people can get a primer on that. If you
Okay.
haven't dosed Kalkwasser solution before, then